So we're going to start by kind of giving a high-level overview of how this app is laid out. This is very common way to organize apps built with Spring. We typically end up having some resources here, which provide various declarative means of explaining where the Spring server, the monolithic app server, can go to find the port to listen on and what time zone to use and what database to use and other properties. These are all just defined declaratively. And we also have the locations to get the data that's needed to load the databases to do all the various work. I'll talk about that when we get a little further along. And then there's a bunch of different services that we have here. Now, in this particular implementation, everything runs within one server process. So we don't have a microservices-based approach. We have a monolithic-based approach. And so in this case, the different services are actually implemented as objects, and they're all going to be co-located in the same address space. So let's kind of start by taking a look at the flight folder, and that's kind of the main entry point that a client uses in order to be able to access the features of this particular monolithic app. This particular app demonstrates how Spring WebMVC, Spring WebMVC, can be used to handle HTTP GET requests using good old object-oriented programming. And this, again, is kind of a baseline. We'll do a lot more interesting stuff later with concurrency and all kinds of other things, but this is just to kind of get started. And the way this works is we've got a bunch of endpoint handler methods that take GET requests that come in from clients through whatever means we use, be it an Android app, which we have, or Postman or a web browser or whatnot. And these methods, these endpoint handler methods, basically take the HTTP requests and map them to Java methods that will synchronously find all the available flights, find the best price for a given flight request, get a list of airports, find departure dates for pairs of airports, and so on and so forth. And this particular controller, like the one we looked at last week, that was the prime number checker, is given the REST controller annotation telling it that this is to be treated as a REST controller. And that causes some magic to happen, and code is generated to make that all get wired together. Speaking of wiring, as we saw last time, we're going to follow the same design pattern that we used in pretty much all of our applications that use Spring. We have a controller, and then we auto wire the service that implements the methods defined in the controller. So the logic in the controller is pretty much just going to be forwarding to the corresponding methods in the service. And we basically have a login endpoint handler method just there for checking that authorization works. But things get interesting down here. So this is the find flights method. You give it a string, which is the departure airport, a string that's the departure date, a string that's the arrival airport, and a string that's the concurrency, or not the concurrency, the currency, which is the desired currency you want to have the flight come back at. Do I want it in dollars? Do I want it in RMB? Do I want it in yen? Do I want it in euros? Do I want it in Swiss francs? Whatever. And those parameters, which come across in an HTTP GET request, which is mapped to this particular endpoint, that is then converted into a method call to find flights. And you can see we take the departure date and we convert it into a local date based on what's passed in, and the departure airport, which is the three-letter code like BNA or ORD or YYZ or LAX or whatever. There are similar methods here to find the best price. So given a departure airport and a departure date and an arrival airport, it'll go and find the best price. So you get back a list of flights that match the departure date and the price therein. And the reason there's a list is because there could be multiple flights that have the same best price. There's also a method that gets airports. and that forwards to the get airports method on the flight service. And then we have find departure dates, where you give an arrival airport and a departure airport, and it gives back a list of dates with the that match the departure airport and arrival airport. And that, of course, would be used to populate stuff on the GUI, so you'd be able to know where you have a flight running from the departure airport to the arrival airport. So I think you'll agree that's all pretty straightforward. There's really not a whole lot of business logic there. You don't have to do your design that way, but I tend to like that. I think it's a nice separation of concerns. You put all the annotations and the HTML, HTTP related stuff, or the HTTP stuff, you put it here in this controller. And then the flight service really just focuses on business logic. And as you can see here, this particular implementation is going to be annotated with the service annotation, and that enables certain things. It enables auto detection and wiring of various dependent classes by something called class path scanning. And in particular, it's going to basically be able to connect it to the flight controller when we have the auto wired annotation here. So it'll automatically do this without you having to define something yourself. So here's where things get interesting. So what we do here, because this is all a monolithic application, is we're going to auto wire a bunch of objects that will be connected to the fields. And we're going to have airport service, and it should come as no surprise that there's an airport service class over here. And we have an airline service, and it should come as no surprise there's an airline service class over here. We have an exchange service, which does monetary exchanges between different types of currency. Should be no surprise that there's an exchange service class here. You can see how the design is really just following this kind of a pattern where each of the I won't call them microservices, I'll call them object services. All the objects that implement these services in the same address space are all going to be wired together, basically matching with implementations that reside elsewhere in the directory structure. So that'll all get wired up automatically to those various services. We won't talk about them right now. And then down here, we have the implementations of the various methods. And I won't bore you to death with all the implementation details, but there's some pretty cool stuff here using various Java functional programming techniques. So you can see here, when find flights is called, it goes to the airline service and it says, hey, please find me all the flights that go from this departure airport on this departure date to this arrival airport. And I want them back as a map of strings to lists of flights. Flight is an object that keeps track of a flight leg. And so that'll be the list of all the flights that map, because it really returns a map of all flights that map the parameter. And then we convert this map into a stream. So now we're going to have, oh, sorry, that was wrong. We get a list here. That was correct. We get a list of these things. We convert the list into a stream. And then we're going to go ahead and create a map that will group the flight values according to their currencies. So you'll get all the flights that are going to be listed in euros, all the flights that are going to be listed in dollars, all the flights that are going to be listed in yen. And so we use the Java streams collect terminal operator along with the grouping by collector factory method to create a map which maps the currencies to the list of flights that correspond to that. And then what we're going to do is we're going to go ahead and take that map and convert it into an entry set of these map entry objects. So it'll basically have these key value pairs, string to list. We convert that set into a stream, and then we go ahead and we convert the from currency to the to currency. So what we're doing here is we're converting whatever currency those things are in, be they in yen, be they in dollars, be they in euros, Swiss francs, whatever. We're going to convert them into a common currency. So in the currency that we want to work in, say dollars. And then we're going to go ahead and return the list of flight objects whose currencies have all been normalized to whatever the exchange service said was the exchange rate. And so you can kind of get a feeling for the nice functional nature of this code. So this is showing off a whole bunch of things. It's showing off how we can connect these endpoint handler methods that are taking HTTP requests and convert them into method calls on Java code. It's showing how we can take the Java code and then do all kinds of cool functional things and object-oriented things to this. And it greatly reduces the complexity of the code we have to write. Here's a cool little method called try to convert currency. It takes the from currency, that's the currency to convert from, and the to currency, which is the currency can convert to. So it might be, again, dollars to yen or RMB to Swiss francs or whatnot. And if the currencies are the same, we don't have to do any conversion at all, obviously. If the currency is different, then we go ahead and call the exchange rate service to get the rate, the exchange rate of the from currency to the to currency. And then we go ahead and do a little bit of math here in order to update the price to take the current price, multiply it by the exchange rate, and then set that to the new price. And we do this using the map method. So this will end up returning a stream of the conversion, the converted currency, if a conversion is necessary. And then that stream, as you can see here, is then collected into a list. A couple other things, just at a high level, find best price just forwards to the airline service, find best price call, find departure dates forwards to the airline service, find departure dates, get airports forwards to the airport service, get airports. And then finally, get rate just goes ahead and forwards to the exchange services get rate call. So you can see once we're into this part of the code, the service portion, we're really kind of in Java land now. We're not really in HTTP land anymore. And so this is pretty much just like writing a normal Java app. The only main difference here from this and just a regular old Java app is that we've taken advantage of the auto wiring features that come out of the box with Spring in order to automatically connect implementations of these services with the fields here that are what are used in this implementation. Okay, so I'll just show you a couple more interesting things. We have, let's go take a look quickly at the airport service. This is kind of fun. So you can see here, this is really neat. This particular class is really kind of a proxy to the JPA, the Java Persistence Architecture mechanisms that actually provide us with the list of airports. And so what happens here is the airport service just as a thin wrapper around this thing called the airport repository, which we'll talk about in a second. It's auto-wired. And get airports just says, hey, repository, give me back everything that you've got, please. And if we look at the airport repository, this is the really cool thing here. And this is the magic of using the Java persistence architecture model. We don't actually have to write any of the code that does the mapping from object method calls to the underlying relational database, which in this case is Hibernate. And that's because we've extended airport repository from JPA repository, which is a helper interface that comes with the Java persistence architecture framework. And we tell it we want to have a mapping of airports to strings. And there's an implicit method called find all that's inherited from JPA repository. And when we configure this whole thing together, it'll go ahead and populate that database with the information here in the resources portion. And you can see here, we've got the schema, which basically says we have the airport code followed by the airport name, and the airport code is the primary key. So we're going to make a table. And then we actually have the data, which is run at startup time and basically says, insert into the table called airport, the information that's stored here, the values that are stored, that are shown here. So you can see it's basically just a kind of a tuple that makes it clear what the mapping is between airport code and the airport name. And this is also one of the things we talked about before about, convention over configuration, or whatever it is, configuration over convention. I think it's convention over configuration, whereby there's a convention that if you have something called airport, they'll have a table called airport, and so on and so forth. Okay, so that's how the airport service does its thing. It's pretty straightforward. So we have a question. Is using the JPA popular in industry? It's definitely very popular in some industries. Obviously, if you're doing something that's Microsoft based, then you would have to use a different approach than the Java persistence architecture, because they don't use Java in Microsoft, but there's going to be something similar. Can you get there? Oh, there's all kinds of different ways you can get various fields, and we'll take a look at some of those. I think there's some examples here coming up. Okay, so that's the airport object class. It's not really a service. It's a service, but only in a sense of being an object. It's its own thing. It's not a microservice yet. We'll do that later. Let's take a quick look at the airline repository. Here we have the airline service. This one's a little bit more interesting because the methods do more interesting stuff. So you can see this also has an airline repository, and we'll take a look at the airline repository here in a second. The airline repository contains information about airline flight objects, and we'll take a look and see what a flight object is. You can see, for example, we have this is an example of a flight. This is an American Airlines, a hypothetical American Airlines flight where we've got departure airport, departure date, departure time, and so on. And then we've defined a whole bunch of values for these things. The dates are probably a little bit off because they're from last year, but so what? Let's assume we have a time machine so we can go back. And this will basically give us back the pricing for a bunch of things. This is just to get the database up and running. And we've also got a notional one for Southwest, same basic idea. And then we've got a schema file that explains what the flight table looks like, what the fields and the columns in the flight table are going to be. So again, that's just another one of these things where we can use this configuration information in order to set things up without us having to write code manually. And that ends up being accessed by a so-called airline repository, which is also a JPA repository, which will take a flight and it's going to give back a long. And you can see here that we're going to have a bunch of different things where you can go ahead and find the departure airport and departure date and time and arrival airport. And this is going to give you back a list of the appropriate things. And there's another one called find departure dates. And in this particular case, you can see that we added a little select query here, which basically tells it to go ahead and select unique or distinct departure dates from certain conditions where the departure airport equals the parameter and the arrival airport equals the parameter, ordered by departure date in ascending order. So once again, you can see you don't actually have to write a lot of code to do the database stuff. This is all handled for you automatically by the Spring framework and JPA and these various annotations like query and repository and so on. So that's all auto-wired together. So we'll end up essentially with a nice database of flights. And then when people call something like find flights, it'll just go ahead and forward there. If somebody wants to find the best price, then we have some real fun here. There's a whole bunch of different ways to compute the best price. What I do in this implementation, and there's other ones we could look at that do it different ways, we get a list back of all the flights, and then we go ahead and convert that flight list into a stream. And then we go ahead and find the minimum price. So we go look through the stream and we'll find the minimum price wherever it is. And then we extract the price field from there. And so we'll end up with an optional double because there may not be, if there's nothing in there, if it's an empty list, there won't be anything that matches. And so this ends up finding the minimum price. And then once we found the minimum price, we go ahead and take the flights list, turn it into a stream, and then we only allow flights in that stream that match the minimum price, whose price matches the minimum price. We only allow those particular objects or those particular elements, those particular flights, to make it through the filter operation, and then we collect the results into a list. There's other ways of computing the best price. This is a pretty clever way that does it, but there's other ways that use other mechanisms. We may or may not have time to talk about that. And you can see again here, we've got this way of finding departure dates, which again just looks up in the repository. So there's a question here. does query automatically execute, or is it just an alias for query call? So query is basically an annotation that is instructing this method to use this query in order to return the results. Now, of course, we could also have written this out longhand by writing the code here, but this particular approach is nice because it's declarative and it does this without you having to write the code. You just give the query, and then the code that's generated for the find departure dates implementation will essentially do that query. So it's again, you're trying to move things from imperative programming to a more declarative style. And then the last thing we'll look at here is the exchange service. This is, again, a service. It's connected to a repository. The repository is used to keep track of the currency that we have. And if we look down here, you can see we've got a schema, which is going to be the exchange rate, the to currency, and the from currency and the to currency. And then we have data here, which is like, converting from US dollars to Canadian dollars, we multiply by 1.32. And of course, these numbers are totally just dreamed up out of thin air. If we really wanted to get serious, we could connect this particular application to some kind of exchange service. And there's a bunch of currency exchange services that are lurking around out there. And we could go ahead and do that mapping in a more sophisticated way. This is just to make things kind of work. But that's one of the cool things about designing software like this. You can kind of stub out something, or you can kind of proxy it or mock it, I guess, as the case may be, and then come back later and have a more sophisticated approach. And you can see all we do here is we just go ahead and look up in that repository the mapping of the from currency to the to currency. So again, very, very little programming. There's a lot of kind of boilerplate code here, which is both a blessing and a curse. It gets a little annoying at some times, but it's also very conventional. It's the same pattern done over and over and over again. And then the last couple things we've got some constants that keep track of things like the endpoint names. These are just the names that'll be translated ultimately into the HTTP requests that come across from clients to the server. We keep track of the services we've got, airport, exchange, and so on. Those are used for various purposes. And then we've got the model, which are basically the classes for the types of entities that are going to be stored in the database. Database is, because it's plural. So here's the airport class. You can see it's got an airport code and an airport name. And that, of course, matches the stuff that we saw down here for airport with the schema. So that's basically just kind of mapping between those different entities. We have an exchange rate class, and you can see we annotate it to indicate what kind of parameters we want to have here. Let's see. Actually, I don't see that we have the builder. I should probably remove that particular. I don't think we actually use the builder here. That's probably in another example. And I don't think we use with either. That's probably another example too. So this is just the exchange rate class. Here's the flight class. Here's the flight request. So these are basically just the classes that we're programming to. And then there's ways of annotating them. So it'll generate things like the appropriate setter and getter methods and the build method and so on, if we want to use the builder pattern. And then these things all get connected up by JPA into the actual implementations that formulate the repository. So that's basically the app. It's very simple. It's got a lot of pieces to it, and there's some stuff I didn't really talk about here having to do with security and so on. But ultimately, here is the flight app main entry point into this particular monolithic Spring flight listing app implementation. And you can see that what we've done here is we've used the Spring boot application, which is basically code annotation that enables the apps to use auto configuration and all the other nice properties that we get by using Spring. So it can do all this magic and do the auto wiring and all those kinds of things. And each of these different annotations has a different meaning. So basically, this is just kind of showing how you get everything up and running. And we can then go ahead and run this application. And if all goes well, it'll start. And you'll see when it starts to run in the little window here, this tells us that it's starting up. It should give us a bunch of diagnostic messages, be able to make sure it's actually doing what we think it's doing. We should be able to do, for example, we should see what port it's listening on. If we read through all this data carefully, you can see it started at port 8081, which is what we wanted to. And you can see after it does all this kind of startup gobbledygook that it's running the application. So now it's waiting for something interesting to happen. So let's give it something interesting to do. So if we come over here and we go down to the tests and we go down to the source test, let's see if I can just go ahead and run these things. And you can see that this starts up the tests in another tab. We've got the application running. If I move let's see if I can move there we go. So move the zoom bar a little bit so it's not quite so much in the way. And the test should be starting up. If all goes according to plan, you can see that they're running, they're doing their thing. The tests are testing various capabilities. And not surprisingly, since the program has been tested many times, all the tests work. And the tests are actually quite interesting. They're just testing all the different entry point methods by using a mocking approach. And you're welcome to take a look at the tests. The tests are kind of fun. But that's a good way to see that everything's working. All right. So, oh, good question. Where do we set the Hibernate database? Let's go take a look at that. That's a great question. So one of the cool things that you'll see about Spring is it's very declarative. And we come down here to application properties in the resources folder. And you can see that we say we want to use the database platform to be Hibernate. And we're using the H2 dialect version. And we set some other properties about where to locate the database. It's an in-memory database, just because we're trying to do something simple here. We don't have any username. Well, we have a username. We don't have any password. I wouldn't advise that in a real program, but this is just a test program. And we set some other things here. These are for security purposes. The username, the password, the ID. Again, you would be more careful in a real project to come up with a better name, better password than pass. But this is good enough for what we're doing here. So hopefully that answered the question about where the database was defined, or was specified, I guess is a better term. Would you set the database relations in the model class? Yeah, so we'll get to that here shortly. I think there's a bunch of videos coming up soon and an assignment that you'll get a chance to see soon that talks about where you set the database relationships. And yes, those are typically in the model classes. That is correct. So those are the main things I kind of wanted to show you tonight. This is a fun little example. It's not really very complicated, but it provides the building blocks for a whole bunch more stuff that is going to be way, way cooler. And yet you kind of get a feeling from the way we've laid out the architecture of the program, how easy it's going to be to extend it and improve it. So just to be more concrete here, right now, this whole thing is monolithic. So everything runs in one address space, and we'd have to use load balanced processes if we wanted to get any kind of parallel computing. Number two, you'll notice that this particular implementation is entirely sequential. There's no use of, for example, Java parallel streams. There's no use of Java concurrency, and so on. So this is a pretty simple implementation. I wouldn't develop it like this in a production system. However, I do think it's fair to mention that the effort required to convert this from a purely sequential server solution to a nice parallel solution is absolutely trivial. And you'll see that as we get a little further along when we look at some of the other variants of this, where we just change the use of sequential streams to parallel streams with very, very little change at all to the structure of the code. And that's honestly why I used the Java streams model in the implementation because I wanted to make that really easy. The other thing, of course, that we will come back and improve in great detail as we get further along in the course is replacing the use of a monolithic server with microservices. So rather than having everything run as objects within the same address space of the flight apps, the flight application, we're going to actually have the services, the airline service, and actually we'll have different microservices running for different airlines. We'll have the American Airlines microservice. We'll have the Southwest Airlines microservice, and so on. We're going to have the airport microservice. We're going to have the exchange microservice. Each of these things will be services that can be running independently of each other. And then the program will communicate using basically the Spring mechanisms. In this first go round, we'll use the synchronous two-way properties that come with Spring WebMVC. And then later, we're going to come back and improve things to use Spring WebFlux. But you'll get a feeling for that as we get further along in the course. I don't want to get ahead of myself here.